All right, welcome to 2.3, Solving Proportions. In order to start this one, I want to kind of remind you of how we solve fractions when we're dealing with this and trying to get rid of a denominator. First of all, keep in mind that when we have a fraction, it's the top divided by the bottom. And to undo division, we multiply. So if we multiply both sides by 6, what we have here is 6 divided by 6. Which cancels out. Not cancels, divides out to equal 1, and then we have 1x, which is what we want. So what we're left with on this side is x. 10 times 6 gives us 60. In a similar problem, we have 63 over x equals 7. Now, if I multiply both sides by x, those two divide out. I have 63 equals 7x. Then I divide by 7. So what I'm left with here is x equals 9. Now, if I have a proportion, which is two fractions equaling each other, for all intents and purposes anyway, I can do the same thing. I can multiply both sides by x. I'm going to put that right there. So I have negative 8x 32, and then multiply both sides by 3. So I have negative 8x equals 96, and then divide by negative 8. Then I have what I don't know off the top of my head. 96 divided by 8 is 12, so this gives me x equals negative 12. The other way to look at that is through a method called cross-multiplying. So if I start with negative 8 over 3 equals 32 over x. So if I have two fractions equal to each other, sometimes it is easier to simply cross-multiply. Mathematically, it's the same process as this, but it's a few steps difference. So here I multiply across negative 8 times x, so negative 8x, and then 3 times 32, so negative 8x equals 96. So really I just saved myself really just one extra step. So it's good to know how to do both, because sometimes if you have a problem like this back up here, then it's easier just to multiply by the denominator. But other times, easier to go ahead and cross-multiply. Again, divide by negative 8, so x equals negative 12. Sorry about that. So now I have a little bit more, but I'm still going to do the cross-multiplication. Now here's where I have to be careful. I'm multiplying 5 by x minus 4. So the way I'm going to write that is 5 times x minus 4 in parentheses. And that equals 10 times 3. And then I'm going to distribute and multiply and simplify stuff. So 5x, 5 times negative 4 is negative 20, equals 10 times 3 equals 30. And now it's just a matter of solving an equation. Add 20 to both sides. I'm left with 5x equals 50. Divide both sides by 5. So I have x equals 10. A couple more examples of those similar types of problems, and then I will let you go. So 11 times x plus 9. Don't forget the parentheses, equals 5 times x minus 10. We distribute 11x plus 99 equals 5x minus 50. Subtract the smaller x from both sides, so minus 5x minus 99 to get it to the other side. I'm left with 6x equals negative 50 plus negative 99 is negative 9. Divide both sides by 6. So I have x equals, don't know that one off the top of my head either, negative 149 divided by 6. Negative 24.83 repeating. And nope, I don't think those are, I think we just leave it like that because it's not a terminating decimal, so I'm going to leave it as a fraction. Finally, on the last one that we'll do as an example, 2 times x, 2x equals 5 times x minus 3. Distribute, so 5x minus 15 equals 2x. In this case, it's not really necessary to take the smallest x away from both sides because what I'm really trying to do is get the x's all over to one side. So I'm just go ahead and subtract the 5x. So negative 3x equals negative 15. Divide both sides by negative 3. So x equals 5. So those are my examples for you for solving proportions. These are all the problems that we did together in class. So I suggest you do those as practice for yourself. And that is all it is for section 3.2. And that's the end of the unit we're doing. It was partly chapter 2 and partly chapter 3. So we'll be reviewing for your test, and the test will be after conferences. Have a good one.